Today we are going to look at a different circuit. It's a bit complicated. It consists of three stages. One is the switching circuit, then another the RF selector, amplifier, and DC converter stage. Then the another stage, that is the RF generator. It is a simple VFO that I just made. It's a LC VFO that is kept a little away. Here we have already discussed about the first part. This is a switching circuit. It consists of a power transistor that can run higher current and higher load. We have currently we have just connected a DC motor here, and we have another stage, that is another transistor here, which is a driver. It's a DC amplifier and driver to this transistor. It's a smaller signal transistor, and we also there is also an LED given there just to provide an indication that the transistor is on. So this is a transistor switching and switching DC amplifier and transistor switching circuit. So here we just connected the output here with the RF selector and amplifier and DC detector and DC converter stage. The function is that we select a RF radio frequency energy that is tuned to a specific frequency that is determined by the coil and the capacitor. Here it's a selector stage, and the selector stage, after the signal is selected, it is brought here to amplify. Here we have a single stage of amplification to boost the RF, the selected RF signal. Then it is given to the DC converter stage, where the RF signal is converted into DC voltage. So we have a variable resistor here to just adjust the required amount of voltage that is need to be provided to the DC voltage amplifier stage. So this is the receiver part, and this is the signal generator. It consists of the oscillator. It's a VFO. It consists of a transistor oscillator. Then we have a buffer stage. So it's a two-stage VFO. So it is tuned to a particular frequency that is determined by the coil and the LC network here. So this is the coupling antenna or a coil, the wire that is closely coupled to the oscillator, the VFO stage here. So when this RF voltage is transferred to the selector stage, it can select this frequency is selected, the signal to the signal frequency. When you tune to the frequency of this variable frequency oscillator, the signal can be it can tune to the signal that is generated by the VFO. Then it is amplified by this transistor. It is DC detected. It is converted into DC voltage then, and it is currently switched on. So that is why the motor is running. So here we have the DC voltage. It is amplified by this transistor, and it is driven to the it is given as a drive voltage to the final transistor. So this is how it is working. So this is the signal antenna it's a signal collector which is closely coupled to the VFO stage. So when I just, so this is how it works. When I connect the when I turn on the VFO, this is the variable frequency oscillator, which is to which the antenna, it is closely coupled to this VFO. And when I just make this, when you turn on this VFO, the entire system works. It's closely coupled to this. So when I remove the coupling, it will just go away. So there is no direct electrical connectivity. It's just through the RF coupling that the small RF signal is selected. You can adjust the voltage here. This is the tuner stage. You can see the LED going to a to a peak level. So when I off tune this LC network, the LED goes off. When I just tune it to the frequency of the VFO, it glows very brightly. And so this is an RF operated transistor switch. So this is how, when I turn this VFO off, it will turn this off, because this RF generation, this is keeping the other circuit work. So when I turn this VFO off, the other circuit, the switch will be off. So it is totally dependent on the VFO. So